Hello, my name is Curtis Strong and I'm a Field Applications Engineer with Laird Connectivity. The goal of this video is to demonstrate how to utilize the BL654 with BLE mesh using a sample Smart Basic light switch, client, and server application, as well as to provide an overview of BLE mesh from an application perspective. To do this, you will need at least 3 DVK BL654s, though when ideal setup, as shown in this video, we'll use 5 to view the interaction with multiple on-off servers. One of these dev kits will be used as a sniffer for mesh advertisements, which helps to better understand mesh as it shows activities such as provision beacons. This sniffer development kit can be either a DVK BL654 or a DVK BL652, as the Smart Basic application will run on both platforms. You will also need the UW Terminal X terminal software. A link to download this can be found in the BL654 mesh supporting documentation for this tutorial video. Next, you'll need the BL654 mesh-enabled firmware found on the software section of the BL654 product page. Note, you may want to place this folder on your desktop for ease of use later, as we will do in this video. The switches and jumpers on the BL654 dev kits should be configured as shown here. Please be aware that if the 4 jumpers on the bottom right of the board are missing, the 4 LEDs will not operate for the demo, which relies on switching the lights on and off. First, we will connect our BL654 to the PC with the included micro USB cable. The power LED illuminates when the board is receiving power. If the power LED does not light up, ensure switch 4 is set to USB as shown earlier in setup. On our desktop, you can see we have the newly downloaded BL654 mesh-enabled firmware, as well as UW Terminal X. Let's open UW Terminal X and click the Accept button on the About screen, and select BL65X in the device drop-down box, and select the COM port for your DVK. Then click OK. First, we will use the ATI0 command to ensure our BL654 displays as the correct device. Then we will use the ATI3 command to check the current firmware version loaded to the module. Finally, return the BL654 to factory defaults with the AT and F* command like so. Please be aware that if you're using a new development board with an auto-run application, you may need to remove the auto-run jumper on J12 and press the reset button to exit out of the sample application, and then issue the AT and F* command to erase the file system and all non-vol data. With the module restored to factory defaults, we will click the Close Port button in UW Terminal X for now so we can install the mesh-specific firmware. To do this, navigate to the BL654 mesh firmware folder that was downloaded from the BL654 product page. Locate the download firmware UART.bat file and launch it. When the configuration launcher appears, select the same COM port that was used to interface with the module in UW Terminal X, and confirm that the COM port is invalid message is gone, and then click OK. In the following box, click Proceed, and when the upgrade is complete, click Quit. Now we will return to UW Terminal X, click Open Port, and reset the module with an ATZ command. Lastly, we send the ATI3 command and confirm that our mesh firmware installed properly. Perform this step on all of the development kits you will be using in your mesh setup. Because this demo uses an engineering firmware build, it is not able to use the online cross-compiler feature of UW Terminal X, so we will need to use the local XCOM file found in our firmware folder. Navigate to the firmware file in the BL654 firmware upgrade folder that you downloaded. Here you will find a file named xcomp_BL654, followed by 8 letters and/or numbers. Right-click on this file and select Copy. Now navigate to your UW Terminal X folder, where you will find a file named Compilers. Inside this file, right-click and select Paste to make a local copy of the mesh compiler for UW Terminal X to use. Next, we will need to label our boards. If you have 5 DVKs, label them Client, Server 0, Server 1, Server 2, and Sniffer. If you are using the minimum of 3 boards, the steps for Server 1 and Server 2 are ignored. Open an instance of UW Terminal X for each DVK and enter the AT command to ensure the board is operating normally. For the board labeled Client, navigate to the BL654 Mesh Firmware Download folder, Mesh Apps, and then drag and drop the autoRun.mesh.light.switch.proxy.client.sp file onto the UW Terminal X instance for your client DVK. We will do the same process for the boards labeled as servers, but here we will use the autorun.mesh.light.switch.proxy.server.sb file instead. And lastly, we will do the same on the board labeled sniffer, but here we will load the autorun.mesh.snif.sb file, which is also located in the mesh app subfolder. Then confirm the application has been loaded properly by entering the at+dir command. Do note, an alternative method of loading Smart Basic applications is to right-click inside an instance of UW Terminal X like so, select Cross-Compile and Load, and browse to the location of your .sb file. Select it and click Open. If necessary, revert the boards into an unprovisioned clean state. If this is the first time you are running this test, and the boards are already in a clean and unprovisioned state, you can skip this step. But if at any time you think the boards may have non-volatile mesh information, or you are uncertain, it's best practice to revert all the boards. So if you clean one, clean them all. First, untick the DTR box. Then tick and untick the break box that sits right next to it. This will reset the module, but will prevent the auto-run application from starting, so it will accept AT commands. Next, send the ATNF 0x10000 command. This erases all flash sectors used by the mesh stack, which places it in an unprovisioned state. Take the DTR box, and finally press the reset button on the module to restart the auto-run mesh application loaded on the board. When you see the mesh state waiting for provisioning message, the process has been completed successfully. Next, we will create and provision a mesh of up to 4 devices. We recommend 4, but only 2 are required. The devices get provisioned using NRF mesh on either iOS or Android, which is developed by Nordic Semiconductor. Note that this video will only use iOS for provisioning, as at the time of recording the Android application is currently undergoing a refresh. Ensure all of your DVKs are connected to your PC with the power select switch set to DC 5 volts so that the board is powered off. Next, switch on the Server 0 board. You will notice there is now activity on the sniffer board. This traffic shows that Server 0 has started advertising, but that it is unprovisioned, and that it can accept advertising either over adverts or via a BLE connection. Please refer to Laird's Mesh app note for a more in-depth explanation on how to read this traffic. Next, we will provision Server 0 via iOS with the NRF Mesh mobile application. First, launch the NRF Mesh app. From the bottom tab, select Settings. From the Settings page, in the Mesh State row, press Forget Network and then Confirm. This will erase all states from the mobile device and create a new mesh network. It also recreates a new random network with 3 new random app keys. Next, confirm the application version is at least v1.0.2. From the bottom tabs, select Scanner. This screen scans for all devices that are in a provisioned state and offers mesh provisioning service via GAT connection. Select the LSP server device to move to the node provision screen. Confirm the following details. The name row shows LSP server. The unicast shows address 0x001. There is a value in app key 1 row. Do note you can edit these rows by tapping it. This is important if you want to allocate a node address different from the one displayed. At the top right, tap Identify to view additional information that is pertinent to the provisioning step. In this window, tap Provision, also located in the top right. This displays a BLE connection message in UW Terminal X, as well as some mesh state messages that show the progress of the provisioning process. When the progress bar at the bottom of the mobile device reaches 100%, the screen will change to the network screen. On the UW Terminal X screen, the mesh state provisioned adder1 count1 message confirms that the address of the first node is 1 and there is 1 element. The network screen displays all the nodes in this network. For now, there should only be one, LSP server 0001, where 0001 is the node address allocated to it. It also has 1 element and 3 models. We only registered 1 light switch server model in the Smart Basic application. The other 2 are the configuration and health foundation models, which all devices inherit by default. LSP server corresponds to the pound-defined device name that exists in the loaded Smart Basic app. Tap the LSP server box to advance to the node configuration screen. This shows details of the 3 models. Tap the Simple On-Off server row to advance to the Simple On-Off server window. Here, tap the app key binding row and select app key 1. The app key binding value now displays keybound with index 0000. Because server 0 publishes to the group address 0xC001, tap Add Value for the publication address row to move to the publication settings screen. Here you see the first row has a default address of 0xCEEF. Tap 0xCEEF. In the dialog box, enter 0xC001 and select Set. Tap Apply Publication in the top right to accept the change and return to the previous screen. Because the subscription address is 0xC000, we're going to tap Add Subscription Address. In the dialog box, enter 0xC000, tap Add, and confirm C00 was entered as shown. Next, tap back in the top left. Here in the node configuration window, an icon in the third row shows two vertical arrows and a horizontal line. This icon means that the model was assigned a publication and subscription address. Now, tap Network in the top left to return to the network screen. On the top right of the network window, tap Disconnect. UW Terminal X will now display a disconnect message, and the sniffer now displays a new type of advert called Proxy Net ID. This is basically the device now advertising a mesh proxy service for the mobile device to get back into the network via a GATT connection should it be necessary. Provisioning servers 1 and server 2 will follow the same steps, the only difference being publication address will be 0xC002 for server 1 and 0xC003 for server 2, as shown in the following setup. To provision the client, select Scanner from the bottom tab. Next, select the LSP client device to advance to the node provisioning screen. Here, confirm that the name row shows LSP client and the unicast address now shows 0x0004. Change the unicast address by selecting the row and enter the address 0x0028. Tap Identify in the top right and then Provision. Note the mesh state messages in the UW Terminal X window for the client on your PC. From the network page, select the LSP client box to advance to the node configuration screen. Tap the first simple on-off client row. Next, tap the app key binding row and select app key. The value should now display keybound with index 0000. Because the client's first model publishes to the address 0x001, we need to change the publication address from the default value. To do this, tap the publication address row and change the default publication address of 0xCEEF to 0x0001. Tap Set, and then tap Apply Publication in the top right. Now we will add the subscription address. To do this, simply select add subscription address, enter 0xC001 in the prompt and select Add. This subscription address allows the client to listen to messages from server 0 based on the publication address we set when configuring the server. Tap Node Configuration in the top left to navigate back to the node configuration screen. Here, select the second simple on-off client row. Next, tap the app key binding row and select app key. The value should now display keybound with index 0000. Because the client's model publishes to the address 0x0002, we need to change the publication address from the default value. To do this, tap the publication address row and change the default publication address of 0xCEEF to 0x0002. Tap Set and then tap Apply Publication in the top right. Now we will add the subscription address. To do this, simply add subscription address, enter 0xC002 in the prompt, and select Add. This subscription address allows the client to listen to messages from server 1 based on the publication address we set when configuring the server. Again, tap Node Configuration in the top left to navigate back to the node configuration screen. Here, select the third simple on-off client row. Next, tap the app key binding row to select the app key. The value should now display keybound with index 0000. Because the client's model publishes to the address 0x003, we need to change the publication address from the default value. To do this, tap the publication address row and change the default publication address of 0xCEEF to 0x0003. Tap Set and then tap Apply Publication in the top right. Now we will add the subscription address. To do this, simply select it. Add subscription address, enter 0xC003 in the prompt, and select Add. This subscription address allows the client to listen to messages from server 2 based on the publication address we set when configuring the server. Now we will add the subscription address. To do this, simply add subscription address, enter 0xC003 in the prompt, and select Add. This subscription address allows the client to listen to messages from server 2 based on the publication address we set when configuring the server. Again, tap Node Configuration in the top left and navigate back to the node configuration screen. Here, select the fourth simple on-off client row. Next, tap the app key binding row and select app key. The value should now display keybound with index 0000. Because the client's model publishes to the address 0xC000, we need to change the publication address from the default value. To do this, tap the publication address row and change the default publication address of 0xCEEF to 0xC000. Tap Set and then tap Apply Publication in the top right. Note this does not have a subscription address as it publishes only to the group address of C000, which will make more sense when we test the network. Note in the node configuration window an icon in the first 3 client model rows shows 2 vertical arrows and a horizontal line, where the fourth has an icon with only an up arrow and the horizontal line, which implies that it has a publication address but not a subscription address. Next, tap the network in the top left row, and in the top right tap Disconnect. Again, you can observe the disconnect and proxynet ID messages in UW terminal if you wish. All 4 of our devices are now provisioned so we can test Nordic's simple on-off server and client mesh model. To do this, we will press button 1 on our DVK labeled server 2. You can see the client received the simple on-off opcode status message in UW terminal X. Server 2 shows button 1 was pressed and that it sent a mesh update, and you can see that LED 1 is now on. We can turn LED 1 off by pressing button 1 again, which also prompts the same set of messages. We will repeat this test on server 0 as well. Lastly, by pressing button 4 on the client DVK, we control LEDs on all the servers as button 4 publishes to the group address of C000, which all of the boards are subscribed to. You can see in UW Terminal X the on-off status messages that are relayed as a result. Thank you for watching this demonstration. If you have any technical questions, please visit our support page for links to support materials and contact information.